two learning targets. The approaching standard part of this work is learning target 2.7. And that's just being able to look at a problem like this and pick out the starting value and the rate of change. Be careful. Sometimes they give you more information than you actually need. One thing to make sure that you're looking at is your starting value and your rate of change should have the same units. Sometimes they throw other stuff in that you don't need that has different units on it. You don't need to write the units on here, but you need to think of that. So if I look at this, the long-distance telephone carrier charges a $1.38 connection fee for international calls plus 36 cents per minute. That means if someone just picks up on the other end and immediately hangs up, but the connection was made, you've already spent $1.38. If 1 minute or even part of a minute has passed, because usually they go up to the next minute, they're going to take that $1.38 and they're going to add 36 cents to that. After 2 minutes, it's the original connection fee, but they're going to add the 36 cents 2 different times. So what you really end up with is my starting value is $1.38. That's what happens at time 0. The connection is made, boom, you hang up, that's it, you spend $1.38. The rate of change is positive because this number is going to get larger by 36 cents for each minute. My independent variable, I want to look in here, and generally I'm looking for the word per or each, and almost all of the time, not quite, but almost, the word that follows that is a clue to my independent variable. Now, my independent variable is not per minute or each minute, it's the number of minutes. And if I think about this, the longer that I talk, the other thing that changes, the more this call is going to cost me. So my dependent variable is the total cost of the call. The independent variable, as you know from science, is x. Your dependent variable is y. My equation, well, the total cost starts at $1.38, but I'm going to add 36 cents for each minute that I talk. I will also accept this if you want to move this around to y equals 0.36x plus 1.38. But my brain starts here. What am I starting with, and then what happens after that? So in this case, we're talking about workout time. He's already burned 400 calories just jogging or running to the workout facility. He's going to keep burning more calories. And how many is he going to burn? 20.7 calories per each minute. Now that per, again, with minutes following it. So number of minutes. Sometimes it's easier to go write the equation and then come back to the dependent variable. So I started at 400, and I'm going to add 20.7 calories for each minute. And then I say, well, if I do this 400, let's say 5 minutes worth of working out, 400 plus 20.7 times 5, and I get the number, what's that really telling me? And that's my y. What it's really telling me is the total calories burned. Don't just put calories, and up here, don't just put minutes. What are you talking about? And don't just put calories burned, because he burned 400 calories to begin with. He's burning an additional 20.7 calories. Oh, I want the total calories. So those two things combined. And again, that's my x and that's my y. Independent variables x, dependent variables y. You need to read these carefully. You have Dallas, and you're driving to San Antonio. And it's 272 miles apart. Now, when they talk about distance and starting value and rate of change, in this case it's really important it's the distance from Dallas. So think about it. I'm starting in Dallas, and so when I'm starting, my distance from Dallas is 0. If instead they had asked from San Antonio, in that case my starting value would have been 272. Because if it's from San Antonio, distance from San Antonio, I would have started 272 miles away. But since in this case they said distance from Dallas, I'm 0 miles from Dallas to begin with. Rate of change. Well, I'm getting further and further away from Dallas every hour that passes, and I'm getting 68 miles further away every hour. Here, my rate of change, if it was from San Antonio, would have been negative 68, because this number, which started at 272 miles, is going to decrease, and I'm going to get closer and closer to San Antonio with every hour that passes. My independent variable, and I'm looking and I'm saying, I don't see the word per or each in here, but I understand that this is miles per hour. So hours is going to be my independent variable, number of hours. Again, you don't like per hour for independent variables, number of hours. Dependent variable. Well, my equation, I start at 0 and I'm increasing by 68 miles for every hour. So ultimately what this is going to tell me is the distance from Dallas. Now here, the independent variable would have been the same. The dependent variable would have been distance from San Antonio, and my equation would have been that I start 272 miles away from San Antonio, but the distance from San Antonio is decreasing by 68 miles for every hour that passes. And then in this one, again, you can always pause these at any point and read and catch up. I start with $1,300 that I invested, but I'm losing $2.58 on average each day. So number of days. And again, my equation, y equals, well, I started at 1,300, and I'm subtracting $2.58 for each day. My dependent variable, I need to be very careful. Don't tell me the dependent variable is how much money you lost or your investment. If you think about it, if it was 10 days and I took 1,300 minus 2.58 times 10, the number that I would get from that is the actual amount that I have left. So amount of money left, or the current value of the investment, or something like that. It has to have all of this put together. Thank you.